Thank you, everybody. It's great to be here. विशाल आ गया कि नहीं? Mathematics pure. This is our last session for this year, and if there are any questions, I'll be happy to take those questions. There are three questions that people have asked, but those are a bit descriptive questions. So those questions will take some time to answer, and it is perhaps better to perhaps have a one-to-one call with the person because there are numbers given and so on. So I'll try to do that. Hi, Nicholas, how are you? Good evening to you too. So I will wait for 1 or 2 minutes to see if there are any questions. Otherwise, I will take questions from there. Good afternoon, Golfin. Nice to meet you too. This is our last session, and after that, we will all be ready for exam. I hope you are all prepared and well set to go and write exam. All the exams are more or less done. All the assignments are done, and today the solutions to the last assignment will also be released. And we will, whatever re-evaluations are to be done, we will do them soon, either tomorrow or on Saturday, so that by Sunday or Monday, it will all be done. So that, we can move on to the exam and the remaining part of the course. And then the only remaining part will be to give grades to all of you. Okay, so among the questions which are asked, I will take one question, which is something which can, be explained by talking here. Okay, so Nicholas has a question. For question of convergent, like for example, the second question in assignment 11, there were two options, 6 and 1350 upon 243. So for P by Q, with regards to the formula, do we use 6 by 1 and 1350 upon 243 or 6 by 1 and 50 by 9? So, I think when I have talked about convergence, I have said that P and Q will be something which will be in their lowest form, because we want to have something about Pn and Qn as well. So when we want to think about the convergence, then the convergents are in the lowest form. But when I write about the following are equal to convergence, then of course, it can be any of these things. So it can be 1350 upon 243, or it can be 50 by 9. All of those are allowed. Okay. Good evening to you also, Mahavidya Dwivedi ji. Very nice to see you all here for the third session that we have. Nicholas, I believe I answered your question that when we have convergent P by Q, then it's in the reduced form. That means P and Q are not allowed to have any common factors. But when the question can be that which of the following are equal to the convergence, then you will have to allow common factors between the numerators and denominators. Okay, so all right, so meaning I will just sum up the course briefly. What we have really been doing is to study number theory with the minimum possible prerequisites. That is what we wanted to do. So we began with the congruences, as you all know, meaning we began with primes really, and correct, Nicholas, simplest form. So 50 by 9. When you are writing a convergent, then it will be 50 by 9. So we began this course with studying primes. We proved infinitude of primes. Then we looked at primes of the form 4n plus 1, 4n plus 3. And, meaning I alluded that there were infinitely many primes of this type. In fact, there is something called Dirichlet's theorem on infinitude of prime numbers in arithmetic progressions. It says that whenever you have numbers a and b which are co-prime to each other, meaning they have no common factor, then you look at an plus b, and in an plus b there are infinitely many primes as you vary n. This is the theorem of Dirichlet, and it requires some parts of analytic number theory. So this is perhaps a course that one might think of doing after this. What we have done is the basic number theory, and after basic number theory, another possible course can be on analytic number theory. So let's see, if I have enough time, I will perhaps give a course on that. So Raviranjan Kumar says, very good evening. Please discuss about the exam question pattern. So, okay, so exam question pattern. There will be, first of all, there are 10 questions of 1 mark each. These are questions of the form true or false. So you have to give, a sentence will be given and you have to say it's either true or false. And once that is done, then there are some questions which are of 2 marks, 10 questions, 10 questions of 1 mark, 10 questions of 2 marks. So in these 10 questions of 2 marks, some small calculations will be required. You will be asked to compute something using very small calculation, not very long calculations. Then little longer calculation will be required to solve the next set of questions, which will be for 3 marks. Again, 10 questions. So we have 10 questions of 1 mark, which is 10 marks, 10 questions of 2 marks, which is 20. So together we have 30 marks. And now we have 10 questions of 3 marks each. So there are 30 and earlier 30. So total we would have 60 marks. After that, there will be 4 questions of 10 marks each. And in those 4 questions, the answers will be really long and there will be various steps involved. And each step will have half a mark or 1 mark. So I will set out the step saying that the answer is of this form, where P and Q are the integers, then where P is less than Q, then P is equal to, then you will have to, whatever given place is there, you will have to write the value for P, and Q equal to. So both will have half a mark or 1 mark, depending on how many calculations are required to find each of them. So that will take care of remaining 40 marks. And so the whole paper will be for 100 marks each. Okay. Sanjeev Karji says, sir, kindly, if possible, explain Ramanujan prime number theory. I don't know what Ramanujan has done in prime number to say something about Ramanujan prime number theory. Ramanujan has done lot of work in number theory, and there are many things which are called after Ramanujan. There are some theories. You know, when you have a theory, it means you have a set of techniques which are developed, which will apply to many problems. So there might be Ramanujan type mathematics or Ramanujan principle and so on. There is the circle theorem and so on due to Ramanujan, but I don't remember having heard about Ramanujan prime number theory. So Vasant Sanku sir is asking, exam is getting near. Would you give us info about the question paper format? I think I have just done that. I don't want to do it again now. I think I'll wait till the end of the session and I will repeat it again towards the end of the section, right? So right now it is say 8 minutes past 4. So perhaps after 40 minutes or so, when we are close to 4:50, that is when I will again explain the format of the question paper. Okay, yeah, you are welcome, Sanjeev. Thank you. Okay, yeah. So, all right. So, Kaustubh is asking, any books we can read which will be built up upon the topics we have done in this course? So, yes. So, the books that we will be, I have already mentioned a book which is by the mathematician, which is called a Comprehensive Course in Number Theory. And Alan Baker, he is the author. He's a Fields medalist, and this is a very nice book written by him. So this is one very good book. But after having done this book, you can practically read any kind of number theory. For instance, you could go into algebraic number theory, you could go into analytic number theory or combinatorial number theory. These are all the avenues which will be available to you because now you have done this foundation course on number theory. Right, Kaustubh? So I think Kaustubh has one more question, which is a rather long question. So Kaustubh, I have noted down your number. You have given a question there. And so since you have given the number, I will perhaps talk with you and explain this whole thing to you. It will be good if we have otherwise theta equal to A2, A3 and so on. Just talking for that will be very difficult. So it is best that we talk about it on the phone. Golfin has, can you give the separate paper for solving part B and part C question? I didn't understand your question, Golfin. The point is that all are computer things. there is no separate thing, in the sense that there are no separate papers. You will have everything on computer in front of you. You can spend as much time on any part as you want. So there is no pen and paper exam. You will be allowed to carry your pen, or maybe pencils will be provided, and then you will be able to do some calculations there. But separate paper for solving part B and part C is something I don't follow, because it's the same paper which is in the computer. There is no pen and paper. So Adarsh is saying that he also has submitted a question. So Adarsh, your question, I will take it up now. Okay, so let's take Adarsh's question now. Okay, Raviranjan Kumar is asking, will there be MSQ or MCQ questions? So there will be no multiple choice questions. The questions will be, there will be multiple choice questions in part 2, which is for 2 marks. But other than that, there are only questions which are, solving a particular thing and writing the final answer. Rough paper given. Rough paper, I think you can ask. So Golfin is asking whether there will be separate rough papers. If you are using given rough paper completely, which is done, then you can ask for more rough paper. Yes, that is possible. Right. Okay, so we'll go to question asked by Adarsh Kumar. Let me read the question. It is given in the Google Sheet. Considering the current research areas in number theory, either algebraic and or analytic or additive, what are your views when whether a PG student who is willing to pursue research in number theory should take a rigorous course in algebraic geometry, or is it fine to not fall too much in algebraic geometry? So this is a nice question, because this is a question which is asked many times, and it's a very natural question to have. The thing is that algebraic geometry is a study of solutions to polynomial equations. So, meaning if we look at x square plus y square equal to 1, and you look at solutions where x and y are real numbers, then you get your usual unit circle, right? Meaning the x and y, which are real numbers, and they satisfy x square plus y square equal to 1. This is the set of elements in R2 which are at distance 1 from the origin. Okay, so you get the whole unit circle of length 1, radius 1. Right. So these are the things which are studied by algebraic geometry people. But the thing is that polynomials on which the algebraic geometry is based and the number theory have a lot in common. So in number theory, we have talked about primes, we have talked about elements, general number being written as product of primes in a almost a unique way, and so on. Same thing holds for polynomials. And therefore polynomials behave as much as like numbers in many ways. Okay, so this not just stops at analogy level, but there is also a lot which one can do while using the things. For instance, there are elliptic curves which are algebraic geometry objects, and these algebraic geometry objects give a lot of information about numbers. So studying elliptic curves is important. If you want to do algebraic number theory or analytic number theory, then studying elliptic curves are very much important. Therefore, all those things will be required when you are doing number theory. So in my opinion, if a student is willing, the student should go for a very good rigorous course in algebraic geometry. So for instance, if the student was going to do the book by Hartshorne, which is really the basic book on algebraic geometry, then I would suggest the student to go for it. Meaning, if I had a PhD student who was working in algebraic number theory and was wondering whether the student should go for algebraic geometry, then I will say that yes, go for algebraic geometry. So that would be the answer to Adarsh's question. Now let me come back to the questions which are asked here. Kaustubh is asking that he has one more question which he has submitted in the discussion forum, and can I ask that question here? So Kaustubh, there is only one question which you have asked, that is on the continued fraction expansion. But that is what I said, that giving answer to that will require some pen and paper. So it is better that I talk with you, because I have your mobile number here. So I will talk with you. If you have any other question, then please feel free to ask. Golfin has said give model questions. Model questions are the questions from assignments. In assignments, sometimes you would have questions which are very easy to answer. And those are the questions which would come for 1 mark. There are questions which can be done with very small calculations. Those will come for 2 marks. So, meaning it is also mandatory for us to give some weightage to questions which are asked in the assignments. Meaning if there are questions which are asked in the assignments, we are asked to give similar questions in the final exam. So many of the questions will look similar to the questions which are asked in the assignment. So if you do assignments completely, thoroughly, everything, then you will have a very good chance of scoring well. Vasant Sanku is asking, sir, is it possible to finish the course in 1 week, giving 3 hours per day? Okay, so I think there are about 60 lectures, maybe 57 or so lectures, which are roughly of say 20 minutes or so. That would means you will need at least 20 hours to 21 hours. And in addition, you will also have to solve assignments and so on. If you really want to do the course, it's better to solve assignments and so on. So 1 week may be too small. 4 weeks is certainly possible. I would say that 4 weeks is certainly a possibility. Meaning there are 12 weeks, so to say. So if you could do 3 weeks worth material in 1 week, then you can complete the course in 4 weeks. That would be a very reasonable speed, provided that you have nothing else to do and you can keep up with the level of mathematics. So 3 weeks would be perfect. 4 weeks maybe. I said 4 weeks because you can do the material work 3 weeks in one actual week. Okay, so Mahavidya Dwivedi has asked, please reply as to why we don't get partial marks for partially correct answers. MCQ have multiple correct answers. Some credit can be given. That is, meaning, it's the policy of NPTEL. And the point is that I want my students to not stop once one correct answer is found. Meaning I want my students to make sure that they have looked at all possible options and found all correct answers. So that is why the policy that is adopted by NPTEL, I really like that policy actually, which is that, you should be able to check whether everything is a solution or not. Typically what happens in MCQ is that, when you know that there is only one answer, and if you happen to get the first one to be the answer, what people would do, for instance, take the example of Chinese remainder theorem. If you are given some 4 choices and said that check which of these will be the solution for your system of simultaneous congruences, people will put these values and check. If they get the value of the first option itself works, then they will just stop and go ahead, which is not the correct thing to do for a student of mathematics. A student of mathematics is not somebody who will, only look at all possible answers and try to choose the likely answer from the given answers. That is not what a math student should do. Math student should do mathematics, and therefore math student should check whether all the options can be correct or not. That is why this policy has been put, which is that, you check all answers, tick all correct answers, and only then the credit is given to you. All right, so Kaustubh has asked another question. While solving question 3 of assignment 11, we can see a pattern in the continued fraction representation of consecutive squares, where if we have a rational number created by squares of consecutive numbers, that is n square upon n minus 1 whole square. These have the continued fraction representation given by 1, n minus 2 minus n by 2 minus 1, 3, 1, n by 2 minus 1, if n is even, and otherwise if n is odd. So this is a very nice pattern, Kaustubh, but this is something which I'm sure has been looked at. Yeah. So this is a good pattern, and you can just quickly write it down and check that the equalities hold. Very good. I am very happy you found this thing. It is very likely, and I am certain that this is something which is very well known. Nicholas has asked, sir, how much similarity is there between NPTEL assignments and the exam as far as this course is concerned? If you could say, please. Yeah, I could say. So I think typically what is expected is that 20 to 30% of marks should be based on assignment questions. So we can change some numbers and some small things here and there can be changed, but the question should be similar to what are asked in the NPTEL assignments. and then similar questions will then come for the exam. So that is something that we have done. So, there is some weightage that one has to do. The course, meaning the lectures that I do, there should be some 20% weightage, which is coming from the lectures. There should be something from the assignments. And the remaining part can be what is called open, but it's not really open, meaning these are questions which are not earlier seen by you, or even the type is not seen by you. Those are what are called open questions. So it's at least 20% weightage. Again, I'm not saying that the questions will come as they are. The questions, the numbers can change and some small things here and there can change. But if you have solved NPTEL assignments, by that I mean you have really solved the mathematics, then you will be definitely able to solve these questions. Good. So you are welcome, Vividi ji. So Golfin Ano says, sir, 2 or 3 assignment answer key is modified. That time you can change the assignment marks or devalue. Yes, certainly. So today evening or tomorrow, I will send the list of all the assignments which are to be re-evaluated. And within 1 or 2 days, you will get an email saying that your marks have been reassigned. I will repeat that, if you have, meaning the proposed answer given by me may be incorrect, and therefore, even if you have given the correct answer, you are not going to get credit for that. But don't worry about it, because out of the 12 assignments, I think we take some only 8 top scores of you. So if there are mistakes made by me or you, we collectively in 2 or 3 assignments, and that is affecting your score, then that's not going to happen, because the top 8 scores will be taken. Kaustubh has asked, is there a proof for this? Proof is exactly, writing down the, n square upon n minus 1 square. This is a rational number. And a rational number has a finite continued expansion, which one just writes down. So what the pattern that you have found, which is 1 n by 2 minus 1, 3, 1 n by 2 minus 1, and the other one n minus 1 by 2, 1, 3, n minus 1 by 2, you should just write it down and see whether this works. If you are really curious about it, I will suggest that you look for n cube upon n minus 1 cube and see whether you get a different pattern in this. So if you are getting n power 3 upon n minus 1 power 3 and do it for some factors, then see whether there is a pattern. The pattern which might be there will be on this n upon n minus 1 power. Meaning right now you have n upon n minus 1 square. Look at n upon n minus 1 cube, n upon n minus 1 power 4, and try to see if there are any patterns coming in that. That would be more interesting. Utkarsh Kumar says, sir, exam date bata dijiye. This exam date must be there on our NPTEL webpage, or you must be continuously getting emails about it. Utkarsh, this information will be available, or, meaning before we stop this session, I request NPTEL staff to put the exam dates. There will be 2 likely dates, and both the dates will be put here. Okay. So, all right. So there was this question asked by Adarsh on whether one should do algebraic geometry, and that I think I have talked about. I was also going to, summarize our whole course very briefly. So we did primes to begin with. After that, we moved on to congruences. Then we did the Chinese remainder theorem, etc. So simultaneous solution of congruences. Meanwhile, hang on, there is something from Golfin. Partial marks is give, sir. So I think he's now asking for partial marks in the final exam. So yes, for each step there are marks. If you get each step correct, then you are going to get those many marks. Okay, so here the marks will be there for steps. Even if you don't get the final answer to be correct, but somewhere up to half the mark, half the point your answers are correct, then you will still get half of the marks. So that will be there. Okay. Sir, are you an internship instructor for NPTEL by any chance? I know that internships aren't generally for mathematics. So Nicholas, I think we were asked whether we can give internships, and I have agreed. And last year also I had received emails about people, and I had suggested them what should be done, but I did not hear back from them, unfortunately. So indeed, I am one of the persons who will give internship. It will be online. I cannot offer accommodation in Mumbai. So it will be an online internship, but meaning it will be one-to-one. We will have discussions at least once a week and so on. So there will be these discussions which will be there. So certainly, if you are up for internship, then you are welcome to apply for them. Thank you, Sridhar. So Utkarsh, there is answer for you that the exam will be on 3rd of November, 2024. All right, so I was reviewing the whole course. I think after doing the simultaneous congruences and so on, then we went to squares and we looked at what are the z by nz where there are square roots for -1 and trying to solve the equations which are now degree 2 equations. So those are the things we did, and in solving that we used all our previous theory also, meaning the Chinese remainder theorem was used to conclude something about solving the equation x square equal to 1 in z by nz. That was done. After that we went to squares in z by pz, and so that brought us naturally into the quadratic reciprocity law. So quadratic reciprocity law tells us when p will be square modulo q and q will be square modulo p. These p and q are two odd primes, and the property of p being square modulo q and q being square modulo p are interlinked in a very nice formula, which is called quadratic reciprocity law. There are actually three parts of the quadratic reciprocity law. First one is simply telling when -1 is the square modulo a prime p. Second is about 2, the oddest prime, the even prime being a square modulo a prime p. And the third one is what I just talked about, which is about connecting the Legendre symbol for p over q and the Legendre symbol for q over p, each other. So that is the next thing that we did. After that, what did we do? So I guess we went to quadratic forms. We went to the study of binary quadratic forms and studied them. We looked at binary quadratic forms. Wow, there is a question. What is the philosophy of number theory? Good question. I can spend whole 1 hour talking about this. So binary quadratic forms is something that we studied. We looked at reduction theory of binary quadratic forms. We proved that once we are given a number d, which is the discriminant of the quadratic form, then there are only finitely many equivalence classes of binary forms of that discriminant. We also computed that in our assignment problems. And towards the end, we discussed continued fractions. So continued fractions are also the ones which led us naturally to what are called the Brahma-Gupta equations, or some people know them as Pell equation. So these are the things which we basically did in our course. This course can be continued in several directions. There can be a course in analytic number theory, which I may give in the coming 2-3 years, or there could be something in algebraic number theory, or there can be an intermediate thing which will discuss about finite fields, little bit complex numbers over real numbers, and some other topic. So the basically algebraic number theory, but at a preliminary level. This is something that one can do, is something that I am actually planning about. So we will see how it goes. I must drink water before answering Vivedi's next question. Okay, so yeah, meaning Nicholas has also asked a question in the Google Sheet. So Mahavidya, please excuse me. I will take this question so that then I know that there is only last question remaining there. The question is about units in quadratic number fields. Okay, so let's look at the standard set of numbers that we look at are the integers. You have 0, which is the central point really when you write the numbers. Then on the positive side, you have 1, 2, 3 up to infinity. On the negative side, you have -1, -2 up to minus infinity. And this has the property that although it's not a field, every element is not invertible. So to get a field, you will have to look at rational numbers. Okay, so for integers, we said that you have 0, then you have 1, then you have 2, and so on. For rational numbers, we cannot say that after 0, this is the first rational, because whatever first rational I think about, there is a rational before that and after 0. right? So if you have P by Q as a rational after 0, then P upon 2Q is a rational fitting there in the whatever tiny space we have. So we have rational numbers, which is a field, and in the rational numbers, everything is invertible. Every non-zero element is invertible. But rational numbers can be written by this very nicely behaved set, the set of integers, on which you can apply mathematical induction, etc., because it's an ordered set. You can talk about what is the first natural number which comes after 1. That it is 2. What is the first natural number which comes after 2024? The next year, 2025, which we will be seeing soon in about 2.5 months and so on. Okay, so this is the property for natural numbers, which is useful in proving several results. So one can try to think about using these kind of subsets inside general extensions of rational numbers. So once you have Q, which is the set of rational numbers, you can take some field extension of that, which is like, you take the Gaussian numbers, which are Q adjoined I. So I is the square root of -1. And once you adjoin the square root of -1, you get a field extension of Q. Then there is the question whether there is a ring similar to Z sitting in Qi. And that ring is called Zi, which is called the ring of Gaussian integers. So Gauss is somebody who has spent a lot of time studying these things. So this is called the ring of Gaussian integers. And once you have this ring, the property of every non-zero element being invertible is gone for a toss, because just as you were in the set of integers, everything was not invertible. Only 1 and -1 are invertible. So the units inside Z are 1 and -1. Unit in a ring is something which is invertible in the ring. So if you were looking at Zi, and I think this is also a question which was asked in one of the assignments, the invertible elements in Zi are 1, -1, I, and -I. So there are only 4 elements which are invertible in the ring of Gaussian integers. Excuse me. Right? So these are called units. So here Nicholas has asked the question only for quadratic fields, but in general, you can take any extension, and in that extension, there is a ring like Z. Z is a subring of Q. There is a similar ring sitting in the field extension. And this ring, again, the property of every non-zero element being invertible goes for a toss. The elements which are invertible there, they are called units. And the group of units can be explicitly described by the theorem which describes the structure of units, which is a group, and it's a finitely generated group. Sometimes it can be infinite group. As we have seen for Zi, because these are imaginary number fields, the group of units is finite. But if you were looking at the quadratic number fields which are real, then there are infinitely many such things, and that is what has given us answers to the Brahmagupta equations. So this is what we have for, this is the concept of units in quadratic fields. So coming back to Mahavidya's question about philosophy of number theory, the philosophy of number theory really is that you look at what is happening in Z and try to replicate it in all other possible rings. So for instance, meaning we have Z, there is a prime factorization in Z. You can ask this question whether the prime factorization holds in the extensions. Meaning you take Qi, inside Qi there is the ring Zi. Do we get prime factorization? Do we get that every number in Zi is a product of primes in Zi? Okay, so prime in Zi would mean that it should not have factor in Zi. For instance, 5 is a prime in integers because there is no integer other than 1 and 5 which divide 5. But if you go to Zi, then 2 plus I into 2 minus I becomes 2 square minus I square, and I square is -1. So 2 square plus 1, which gives you 5. So 5 is no more a prime inside Zi. So some of the primes which were primes below, 3 is a prime in Z, it remains a prime in Zi. But there some of these primes will not remain primes. They will be factored into smaller sets in the sense that the norms are smaller. And the philosophy of number theory really is to solve many of these equations trying to imitate whatever has happened in the ring of integers. This is very broadly the philosophy. But other than that, there are many types of number theories. There is analytic number theory where one uses analysis, complex analysis mainly. Prime number theorem is one example of this, which proves that the primes up to x satisfy some particular equation asymptotically. Then there is algebraic number theory, which uses algebra or sometimes even algebraic geometry. There is transcendental number theory, which uses completely different tools. So various number theories will have various philosophies, but the basic philosophy is to understand the nature of numbers in the sense of understand the nature of real numbers and complex numbers. This is the basic philosophy. So Mahavidya Dwivedi has further said that, sir, I think giving assignment, solving questions and scoring good marks are okay. What's the benefit if we don't know the depths of number theory? Very true, of course. Meaning this is true for any subject. But this, this information, the inside information will not come very easily. Typically, what one has to do is to, read a lot and also think a lot, meditate a lot upon all these things. So I think, there was this question, there was this, uh, just one second, I just forgot who had given that. Right. So Kaustubh has observed this n square upon n minus 1 whole square. This is something which is really good, meaning it was not asked in any question, but he just observed that, meaning what, if I remember correctly, there were some options in the exam which looked like 144 upon 121, 169 upon 144 and so on. And I'm very happy that Kaustubh went ahead and computed the continued fraction expansion of these numbers. So this is what will tell you what is going on behind all these things. To go into depths of number theory, you have to put on the swimming suit and you have to be ready to dive inside it. So we have to get in correct tools and then we should spend time studying it. That is what one should do. Okay. Golfin has asked this another question, that Chinese remainder theorem, it's about pairwise primes, but the assignment questions are not pairwise primes. Very good. But one could solve the assignment questions also using Chinese remainder theorem, right? Because what one does is that the system of simultaneous equation that is given in the assignment will give rise to another system which will then involve the pairwise coprime numbers. So let me try to give you an example offhand if I can give. Suppose I want you to find something which is congruent to 1 mod 12 and so what would happen typically in that assignment question is that there is something which is modulo 12 and then some another number which will have 4 as the common factor with 12. So this 1 mod 12 becomes 1 mod 4 and the other number which is, say, let's say 5 mod 20, that will become 5 mod 4 because 20 divides 5 minus something. So 4 will divide 5 minus something. Therefore, the number is 5 modulo 4, but 5 modulo 4 is again 1 modulo 4. So 1 mod 12 and 5 modulo 20 is a consistent system in the sense that you look at prime factors dividing these numbers, prime power factors. So you will have a system for 4 and then you will have a system for 3. So let's go ahead with this question. 1 modulo 12 and 5 modulo 20. Can we solve this? Now here we don't have common factor to be 1, right? These numbers are not coprime, but the common factor is 4. And once you have 4, you get 1 modulo 4 from 1 modulo 12 and you get 5 modulo 4 from 5 modulo 20, which gives you again 1 modulo 4. And further it gives you 5 modulo 20 means 5 modulo 5, which is 0 mod 5. So the number must be divisible by 5. The number must be 1 modulo 4 and must be 1 modulo 3. Now, what are the numbers which are 1 mod 3 and 1 mod 4? These are exactly the numbers which are 1 mod 12. So forget about 4 in the 20. It should be divisible by 5 and should be 1 modulo 12. 1 modulo 12 and divisible by 5. I think that number now is 25. Because 25 is 1 modulo 12 and 25 is 5 modulo 20. So this is the answer and then you go, 12 and 5, so 60. If you add 60 to 25, you get another answer, and so on. So this is how one can start with systems which are not giving you co-prime moduli, but the systems are consistent, and therefore if you go to prime powers, then you will get the Chinese remainder situation, which you can apply and get the final answer. Very good. Thank you for reminding me about this. So Vaibhav Shvakarma is saying, sir, the exam format which comprises 4 questions of 10 marks each can be harmful for us. No, why do you think so? No, why should it be harmful for us? Us meaning let me also come in your group. So he says, suppose if we are stuck at any step, then we lose 10 marks. Oh, why do you think like that? Meaning you will not be stuck at any point because the steps will actually be, told in some sense to you. If you have to get the final answer, then I will say that supposing the final answer is of this type and so on of this type, then what are the things those are things like which are giving you hints. So don't worry. If you have done your assignment questions, I think you will sail through without any problem. And there is also something which I keep saying. Whenever I teach here in IIT Bombay, I tell my students that if there is some question which you think is becoming very difficult, then probably you are thinking in the wrong direction. Because if your if your instructor has asked you a question, that means the question can be solved using things which are done in the course. This is something for which you should trust your teacher. And so if you are not able to do it using things in the course, that means you are in the wrong direction. You should come back and start afresh. This is what I tell all my students. So I will tell the same thing to you, that don't worry, there is no harm in trying out those large questions. Tripathi ji is asking that there is no descriptive solution of assignments on portal. That is true. What has happened is that, many times, so this is, I think, perhaps third or fourth time I'm giving the course, but each time I change the assignment questions. That's the reason also that, some assignment questions I make mistakes in giving answers, because almost each time I'm giving you the new set of questions. And therefore, every week writing down all questions, checking the answers, putting them into the correct format on the NPTEL website and so on takes time, which is in addition to whatever other things I do here at IIT Bombay. So perhaps what I could now do is that after having done it 2-3 times, I will go again to my original set, and then I may be able to give some descriptive solutions, but maybe some hints, even if not the full solutions. This is something I can try from the next time. So although meaning, unfortunately, you had to suffer because there were no complete answers given to descriptive assignment solutions, your juniors will have those answers. So that is something that we can look forward to. So Mahavidya Dvivedi says, always ready for mathematics. Yes, that's the spirit to go. Thank you for kind words. You are also welcome. Thank you very much. Stepwise marking, I do not understand. This is what Ravi Ranjan Kumar says. Yeah, so meaning, unfortunately, I don't know how to do it by giving an example without really divulging any of the things which are asked in the question paper. So what could be a good way to give you an answer on this? Stepwise marking meaning, whenever we want to complete some final answer, there will be some steps which you have to do. And what could be a way to go about doing that? So what is a question which is something at the elementary level, and it will require some calculations so that I can ask you. Yeah, so here is the question. Suppose I give you a large number, and my final goal is to get the prime factorization of the number from you. This is my goal. So my step 1 will be, does 2 divide the number? This will be the step 1. And you answer saying yes or no. And the correct answer will have 1 mark or half a mark. Now, given a number, the number may be a 10-digit long number. But given a number, it is easy to tell whether 2 divides it or not. So the first step, does 2 divide it or not? And the answer being yes or no, could be for 1 mark or half a mark, or the question can be, write the highest power of 2 which divides the number. Now this will require some work, right? Meaning you are given a number of some digits. You will, by looking at the last digit, you will be able to tell whether 2 divides it or not. Maybe by looking at the last 2, you can tell whether 4 divides it or not. Last 3 will tell you whether 8 divides it or not. If you know those things, then you will be able to quickly tell what is the highest power of 2, which divides that number. Okay? But if somebody doesn't know that, then the person will have to keep dividing by 2. Suppose the number is 10 digit long, you divide by 2, you get another even number, you get divide by 2, get another even number, and so on. And then ultimately you will be able to see that 2 power 5, which is say 32, divides the number, and 2 power 6, which is 64, does not divide. So this will be the answer for the first question. But once again, your screen will have, there will be a calculator in the paper itself. So given the 10 digit number, you can quickly divide by 2. So you don't end up doing mistakes. If you keep dividing by 2 by hand, it is possible that you may make a mistake somewhere and get an incorrect answer. So here, while writing this question, you will be able to use the calculator which is given in the question with the question paper itself, and then using that you will be able to write the answer. So this would be step 1, and then there are the further steps. So the next step will be what is the highest power of 3 which divides it. Next could be what is the highest power of 5. And when you have divided by powers of 2, powers of 3, and powers of 5, now the remaining number, is it a prime? So these will be the steps, and these steps will help you solve and reach the final solution that I intend you to reach. This is how the steps will be given. Fazila has asked a very difficult question: how to calculate the class number of a negative discriminant h of minus d. I think this is discussed at some length in our course. So the thing is that there is some now I don't remember it offhand, but there are some inequalities which one have with the given d, and the possible numbers which you can have satisfying the inequalities will be the class number of the given discriminant. So that way it is easy to calculate. I think this might be, please check the numbers, lectures from 40 above and so on. That is where you will find the discussion on quadratic forms. So there are constraints, of course, and I think I have talked about it. Meaning whenever whenever the class number of a negative discriminant is discussed, there are various possible things that you can have. And meaning after all, your quadratic form will be reduced, and a reduced quadratic form has to be of some certain type. And then the b square minus 4ac has to be your discriminant minus d. So you should have b square minus 4ac equal to minus d, and some inequalities among the ABCs will have to be satisfied. So that already gives you some bound, which is that you don't really have to check for all the numbers. So that is the thing which will give it. It is answering the same question that Nicholas also had. So this is what we have. He says he asked this in the last session as well, but he is still confused. Golfin says your testly teaching is good. Okay, thank you. You're welcome, Golfin. So we are getting towards the end of the session. If there are any other questions, I would be happy to discuss. I must say again that Kaustubh has asked a very good question, which is something to do with the lectures, which means that he is reading the lectures and following them very carefully. But unfortunately, I cannot answer the question here because it will involve a lot of calculations and so on. So I will just talk to him and I will explain it to him. Kaustubh is happy for this course. I also enjoy taking this course many times. Thank you. Thank you, Ravi. It's pleasure to teach this course. So now we are towards the end of the session. What is the pass mark or qualify marks for this course? I think 40 or 50. This is typically a passing score. Now we are getting towards the end of this session. So let me repeat again the pattern of the questions, the exam paper. So the pattern will be as follows. There will be 10 marks for, there will be 10 questions for 1 mark, which will be true or false type questions, where you will be asked to a sentence will be given and you should just say whether the sentence is true or false. Then there are 10 marks which are for there are 10 questions which are for 2 marks. These will involve some minimal calculations. After that, the third type of questions will be 10 marks for 3 questions, 3 marks each. These are 30 questions already, 10 plus 20 plus 30, so 60 marks are covered. And then there will be 4 questions which will be real, these questions will give you satisfaction of having done something good. So these questions will have a lot of steps, exactly as I have told in one example of how the steps will be given. So there will be these steps. I will ask you what are these things, what are that thing, and so on. And those will be all for 10 marks. So total we will have a question paper of 100 marks. So I think that completes our discussion today. I will just wait for a minute or two to see if there are any further questions coming. Otherwise, we will call it an end. And I wish you very best for the coming exam and all the exams after this. So, Nicholas, thank you for your kind words also. I look forward to teaching another course. Yeah, I will take some course and I like teaching. As you can see, I like talking, so I like teaching. Therefore, I will indeed. And there are some course ideas in my mind, and maybe some courses which are typically not given elsewhere. So those are the courses that I will perhaps take, and then we will see how it all goes. Okay, so perhaps we can stop. Any suggestions for further studies? Sure, get in touch with me over email and I'll let you know. Namaskar.